And over here we have 4 charges with identical magnitudes that are evenly spaced along the y-axis. So the first question we're asked is to calculate the dipole moment for the dark and light dipoles. And we know that dipole moment is equal to the separation, or the distance, between the 2 charges, positive and negative, multiplied by the magnitude of the charge, one of the charges. And we know that the dipole moment points from negative to positive. So given that information, we have that the dipole moment of the dark and light dipoles are equal in magnitude and opposite in direction. The next question we're asked is to draw arrows at specified observation locations of the direction of the electric field. All distance d much greater than s. And when I visited one of the professor's office hours, he advised me to look at the problem as if it were point charges I was looking at. So in that case, if we kind of disregard d is much greater than s, and we look at this question in terms of individual point charges, we see that, first of all, the negative charges are closer to observation locations B and D, and we know that the electric field of a negative point charge points towards that charge, so our electric field will be pointing inwards. And then for observation locations A and C, the positive charged particle is closer to both of these locations, and we know that the electric field of a positively charged particle points away. So that would be our direction of electric fields. So then we're asked to calculate the magnitude of the net electric field at an observation location A. So what we do is we take the sum of the electric fields of the dark dipole and the light dipole. And we know that the electric field for a dipole is equal to our constant multiplied by 2 times charge times separation over r cubed. In this case, our distance r, so that would be the distance from the center of the dipole to the observation location, would be either d plus or minus s over 2. The distance from the center of the dark dipole to our observation location, our desired observation location, will be d minus s over 2. And then the distance from the center of our light dipole to the observation A will be d plus s over 2. And we then sum that, and we have our final result. And then we're asked, considering an observation point that is presumably infinitely far away from the origin in any direction, is the magnitude and direction of the electric field, does that resemble a point charge or a dipole electric field? And this is another thing that I ask just for clarification at office hours. And I was told that this is a quadrupole. So quadrupole is essentially collectively 4 charges, 2 negative, 2 positive, and this is the electric field at an observation far away would not be similar to either the point charge or dipole, because this is a quadrupole.